this is the first propagation step only. First propagation step. We can still calculate the delta H, the enthalpy changes of this step, by using the bond dissociation energies. So I hope that you pay attention to this. You have to break this carbon and hydrogen bond here for the propane. Then you form this radical. So that takes about 98 kilocalorie. Chlorine radicals already came as a radical, so you don't have to break them up. So nothing you need to do for that. But as a product side, this is a radical, so you don't have to do anything. But that's you're forming a bond. So you are making a bond, so it's going to release about 103 kilocalorie. So in overall, total energy is about -5 kilocalories. So chlorination of propane goes faster than the chlorination of the methane, even for the one position. But the two position, meaning this is actually the secondary carbon there. The secondary carbon is hydrogen taken away, takes a less energy, 3 kilocalorie more. Forming an HCl is the same amount of energy, 103 kilocalorie. So you add all those together, so -8 kilocalories. So that secondary radical formation is about 3 kilocalories, or let's take less energy. So some may think that, yeah, just a 3 kilocalorie, who cares? That may be happening as fast as the other one. But you already know the answer. This happens 4 times better than the other one. 3 kilocalorie does not mean that it's just a little change, like a point, 10% better or 30% better. 3 kilocalorie meaning it takes a person of 4 times better. So that's what it is. And then at this, I want you to see the differences of the calculated delta H. Remember the things we talked about? This one, you are having a methane chlorine molecule. If this chlorine becomes a radical, replacing that, this overall reaction is this. In order to calculate that, you are using the bond dissociation energy of the chlorine molecule and the bond dissociation energy of the carbon and hydrogen. Those two terms been added. And then you are forming the chlorine carbon bond of the methane and then HCl. So these bunch of energies released due to that. So you got the 4 terms in there because you have to break 2 bonds, forming a 2 bonds, overall 4 bonds in action, right? This one, the difference is some came as a radical. If it stays a radical, there's nothing to break. There's chlorine bonds not breaking there. That's the reason you don't see these terms there, right? Because it came already broken. So you're not using this number for that one because you're not breaking the chlorine bond. And I want you to see the difference. Same reason. On the other side, that was a chlorine carbon bond was made. That's why this much energy was released. This stays a radical in these reactions. So we don't have to form chlorine there. So you don't have to just imagine any step that you used to see in other questions. When we ask a question, calculate delta H, you only look at that particular reactions and then only consider about the bond getting broken or bond getting formed in this reaction, not the one that you have seen previous 9 or some other situation. So that's I want to see the differences, how you do differently at those two.
So is this just for
This one?
Yeah.
That one is just the first formation step.
Okay, but so
Well, it came as broken, so initial steps are already there. But we not if this was a reaction that we are asking you to calculate the H, you don't concern about the chlorine breaking the chlorine there because it already came as a broken. That energy already been taken care of, right? So you have to see what's in action only for this one, for to calculate the H of this one. Compared to that, this one is that you have to break the 2 bonds there and forming the 2 bonds. So you have to put everything there. But this one, you're only breaking 1 bond and then you are making only 1 bond. So things are different.
The bond association and what everything associating, we don't look at the point of association and everything's connected over the formula, we only look at the atoms connected.
So you're talking about if it's a propane, can I use a methane as a source of the
Yeah,
bond.
like here, like you're using propane, you're talking about the propane and hydrogen separating, but when you're talking about the chlorine form, you don't talk about the chlorine form with propane, the same form.
Oh, this particular one, there's two things, it has to be exactly matched. If it's a propyl, I mean, if it's a butane, if I'm asking, then you're gonna find the ones with butane. Ones with chlorine wouldn't be applied. I mean, it may be closely approximated, but, you can easily see that. Depending on which hydrogen is broken, this one takes more energy, that one in the middle, that one takes less energy. Even the same molecule, you gotta figure out where the reaction happens, which hydrogen taken out. So you have to find the right one. That's the thing, is that, goes with the soul of this question.
So why don't I look at it as a
That's the thing, because it's a different energy. It takes more energy, that takes less energy. So you gotta pick the correct matching.
okay, good for the formation, like removing energy to form one, why don't we do propane connecting to the form, not just side hydrogen?
For this one, because
Okay, that's
it's not products here. This is the first propagation step. We're not making products yet. So that's the whole reason I'm showing these two and tell the differences. This was overall reaction. You're seeing the products there. This is the first propagation step. We're not seeing the products yet. So that's why chlorine carbon bond is not in actions. Right? I hope you can see the differences, because sometimes we give this type of thing to ask you to calculate the delta H. Sometimes we give reactions like that to give a calculation of delta H. And then you gotta see, you just cannot manually do the same way for everything, right? Because this doesn't have a product there. It only have a radical. And if it stays a radical, doesn't mean that it does not form a bond, it does not break a bond. So that's why the combination part is not there in the calculation. So